Welcome, everyone, to another session of Your Desk University. We are in for a treat. You might say I say that every time, but really, we're going to go through 30 minutes of the most intense introduction to rest that you've ever had. I am so blessed to have Adam Sheether with us today, and he actually has 20 years of Revit experience, and he's been doing automation for over 14 years inside of our industry. So he was one of the original Bad Monkeys, which, if you don't know, that was a group that kind of kicked off kind of digging deeper into Dynamo together. A lot of names out there that you might recognize. But with all of that, I feel like it's only time to bring him onto the screen here. So, Adam, thank you so much for joining us today. Say hi to him. If he says something good, hit the like button. If he says something you disagree with, there's that other one out
Well,
there.
you can't see the dislikes anymore, so you'll just have to tell me behind the scenes.
Okay. Before we get started, I have to ask you, what is your
Please.
number one tip you would recommend people who are in the computational design space?
Oh. Um, if you're in the Dynamo computational design space, funny enough, well, it would be until the search comes out. Download Monocle, because if you're just starting out, and shout out to John Pearson, that thing is going to help you just find the nodes that you're looking for. So that is probably like number one tip for getting started. And then yeah, probably in the last few weeks, then it'd be if you're not already using things like ChatGTP and Copilot, you'll see some pretty cool examples, but it's definitely just flipped the way I've worked in the last couple of weeks. So they're probably my basic tips, but yeah, Monocle to start. And then there's just so much information out there. So yeah, it's pretty good now. It's a pretty rich ecosystem,
I
which is
mean,
awesome.
Monocle does a lot, and John Pearson does a lot for the
Yeah.
community. And I think it's only right that next to the top tips of use GitHub Copilot is John Pearson. Just know how much we appreciate use Monocle. Like
Yeah.
that's where these rank. All right.
Pretty much. Pretty
Yeah.
much.
All right. Well, with that, why don't we dig into rest and see what we can learn? Let me pull up your screen here.
All
There we
right.
go.
So this will be pretty full on, I think. Aussie term, sorry, hectic. As Timon pointed out, and Timon, feel free to jump in with questions if I like say nonsensical
I'm right
things that you
here.
think might be worth. Intro we've already done, so talked about all that. Started off CAD, jumped across, and now work on BIM Beats with Conrad, who's the CTO, and then Automation, which is our consulting team in Australia. It's got 10 people doing a lot of Forge and that sort of stuff. So there's my corporate spiel.
I do want to pause there for a moment because
Yeah,
sometimes
go
I
for it.
hear people who are drafters saying that there's no future for them. And I just love how you've created
Oh,
this future from the title of the group of people that I hear most saying, I just do what I'm told and there's no future. And I just appreciate that. It's really powerful.
I think the technology's opened up a much bigger future for technical stuff because like engineers and same with the architects, especially ones that are really focused on design, which is important, they just don't have time to learn all this stuff anymore. And yes, there's going to be a level of democratization of the tech, but I think you're already seeing like technical people moving more into like the coordination space and the information management space. It's like all of these things. Like if you base it around your core skill set, as in I draw lines in AutoCAD,
Mm-hmm.
and that's who you identify as, then yeah, you are going to be
Mm-hmm.
stay in that position. But if you identify as, I'm here to support, I know the technology, I can
Yeah.
help bridge, the production side and automate the production side. There's a huge future in this space. So
Yeah.
yeah. So, um, yeah, all right. So we'll jump straight into it. So as I said, there's going to be pretty hectic. So I just want to start with a basic. What is REST? So REST, if you've never heard of it, and this will build this stuff from scratch, is just their web APIs. It's how a lot of the internet, how you can talk to the internet. You've heard of web APIs, hopefully from, I don't know, more closer examples like Autodesk API and things like that. But there's a Twitter API. Virtually every web service out there has some sort of interface, and what that allows you to do is connect with it. and query it for information. So similar to the Revit API on your desktop, this is just all of these services having them. The important thing to note with REST is it's an architectural style. So it's not a library. There are libraries you can download, but it is an architectural style. So it's a really cool example of where the global dev community got together and went, we need a consistent way to all chat to each other. So when I go, I need a GET request, and I ask your service for one, I get the same feedback as everyone
Mhm.
else. So it's really cool that it's one of the best examples of global consistency. And the other thing is it does a lot more than just data. It does video and images and stuff. So if you've heard of GraphQL, and I think some people
Mhm.
might have, and if they're ever wondering, oh, should I use GraphQL and REST? GraphQL is just a different way of querying, but it is just mostly about getting the JSON data. So REST is a little bit more agnostic, and you can stream back video and images, XML, any sort of data. The other thing is it stands for representational state transfer. That's the full name. And what it actually does is when you query a service, the reason it's called representational state transfer is the backend never changes when you query it. It's your front end that changes. So if I send a query like, hey, show me a list of projects in the website, the backend just returns that list. Nothing changes there, but your front end then will usually display some sort of list of projects. So that's why that's the name. It transfers the state usually back to a client to then use that information for something else. All right, so why use REST? Why not just connect straight to a database? The main reason is if you just give developers or anyone access to your database, they can do anything to it. They could delete all your Twitter users. They could do all this stuff, right? And the other thing is probably more, that's probably one problem, but more importantly is you usually design a database in the way that you grab data and post data in very specific ways. So REST really allows you to be very intentional, like, hey, here's the calls and here is the things I want you to query. Here's the things that I want you to do. You're not allowed to delete the element ID because I need that. So you can make these very intentional decisions for the users, right? Data is separate from logic. So there's a good point where you can query the database and return the logic, as I said before, images and all of that. And we can do basic calculations too. You don't always have to just fetch data from the database. You can just return some sums, and we'll see that soon. REST is really simple. Again, I know we're delving into the details, but basically, application state and functionality, everything is treated as a resource. These are sort of the rules, I guess. Every resource is uniquely accessible using a URI, which is kind of like the REST version of a URL. So every time you type a web address into your browser, that should go and access one thing. You access all data the same way. So you send a web address when you want to get an image, when you want to get a video, when you want to get a piece of data, all of that. Data is all the URIs are assigned to individual records. So no web address should connect to multiple. And then you've got this client server approach. So you have these two separate things. And REST is stateless, which again, like I was saying before, it's the client side that usually updates. All the instructions in the web address give everything it needs to make to run the calculation or
So I'm
fetch
going to
data.
pause you there for a second. Is
Please.
stateless, for
Yeah.
those who don't work with state, what is stateless?
Okay, so stateless is where you need to be. So in Revit, to move a wall, you would have already had to have opened a file, gone to a floor plan, clicked on the wall command to be able to be in a state where you can start drawing a wall. So you have had to have done all these things, and Revit obviously has to remember where you're at too, because if it doesn't remember that you've opened the file, you're going to have problems. So whereas REST is stateless, is I could go and add a new wall directly from that web query without having to open anything, find anything, do anything. All of the instructions are contained in that single web address, and so there's no need for all this predecessor steps, and that's what stateless is in applications. So thank you. The actions or verbs of REST. So there's a whole heap of them because as always with humans, we started off with these four and they're still the 99%. And then we're like, hey, we need this one and this one and this one. Now there's like 20. But again, most people just keep it simple, right? Don't go fancy. This is all you do with calling these. So a get goes and gets the data. Post creates a new record of the data. Delete deletes the data. and a put doesn't update on existing data. It's that simple, guys. And again, when you boil it down to these 4 things, this is pretty much how the whole internet works on these 4 requests, basically. So a typical approach that a developer might take, and I'll bring back the Autodesk example just because it's a good one, is we might go get a list of things. So I'm getting into my BIM 360 or ACC Build Hub. Hopefully most people are familiar with that. I go and call a list of things. So I'm going to get a list of projects. I get one of the details, maybe the first project, and I go, okay, get me the ID of that project, and I'm going to return that project. Then I might want to update the address of that project. So with that ID, I go, okay, add the new address, and then maybe I'm sick of that project at the end, so I then post a delete, and it'll remove that from the system. So a little fancy little diagram that I did because I'm very good at diagrams. Just pretty simple, guys. The developers over here, we send the web address. Server comes back, goes to the database or whatever this backend is. The developer doesn't have to care about any of this, which is awesome. It comes back with the list. That list comes back. The developer goes, awesome, I've got this list. Now I just want to get project 1. Send that back. It goes and retrieves the details. Now it knows what it's looking for and sends that back as well. And that's REST. And then you just keep doing that again and again to achieve or update various states of data. So what does this look like in terms of graphics? So what we've got here is, so we can see a list of projects, so typical web address. So after this point here, this is the start of your URI or your parameters. So this is basically a GET request that's saying, go to this website and get me the list of projects. Now where REST is really cool is we can go get the projects, but maybe I'm dealing with an application that deals with XML. So I don't want this to return as native JSON, and we'll see that if you haven't, most stuff these days is dealt with in JSON, which is just a text format, schema, sorry. But maybe you're dealing with XML or some other flavors. So you can inject this and go, hey, I want the data back this way. And then from there, I can then go, okay, now I want to get a single project. So again, if the developer's implemented and following proper protocols, I can just go get the projects and then get 001. And it's like, oh, cool, I'm looking for that project. I'll return those details. So you can do these very simple calls to turn the state you're looking, or the results you're looking for. When you get a response back, if you've done something wrong, REST is pretty good at telling you. Again, there's a ton of codes. I'm not going to get into them all. These are like the main ones that you need to start out with. So 99% of the time you're looking for, okay, it worked, no problems, awesome. If you're creating a new thing, if you're sending a post request, you should get a 201, which is like, hey, it successfully created the object. 400's a bad request. You wrote your web address is not formatted correctly. You did something wrong. Go and fix it. Mm-hmm. These 2 are a little bit tricky, but they are different. Unauthorized means if it's a service that you have to authenticate with, you haven't entered the right credentials. You're not an authorized user. 403 forbidden means you are an authorized user, you just don't have the permissions to access that. A huge one that everyone sees all the time on the internet is the 404 not found. So every time you see that, you know that there's a web service on the system. It means it couldn't find the record because every URI has to have a resource. If the resource doesn't exist, you will see 404. And 500 means our server broke, or whoever you're interacting with, their system broke. So I'll touch on this later, but go through the basics, but this is a high level of the 100, 200, 300, 400 series. These are not LODs. Just want to make that clear. We all like to come up with these 1 to 500 things. It doesn't matter what industry you're in, but it's weird. Anyway, so informational success, redirection, client error, server error. Real quick in summary, and I'll jump in an example. So I'll literally use the project example in the Autodesk one, just have a quick look. So if we come across here, this is the Autodesk Platform Services documentation. So everything we've just talked about is in here. So yeah, it's a little bit of blurb. So we need the hub ID. So that's like your Autodesk hub. We're getting a list of projects, tells you what's going to happen. We come down here, there's the URL. You can tell it's a GET. It's only doing a read. We're not doing any writes. We've got authentication, which we're not going to discover in here. We've got one parameter that we need to put in, which is the hub ID, because everyone's got their own hub ID. We've got some query strings, so maybe we want to filter for a particular project, or maybe we want to return only a specific number of projects with pages, or limit the results, because if you've got 10,000 projects, you might not want all those results. the HTTP code summary. So these are all the possible codes that this service should return. So if you're getting anything outside of this, report it to development. And then lastly, if we get down here, here's the actual result that we send. And then this is the example of the result that we get back. So most web services are pretty well documented like this. And then here's an example. So again, if we get to the hubs and the projects, the key thing to always remember, if you remember nothing else, is the question mark is the most important piece. The question mark is what separates the sort of top header information with the parameters or properties. So if nothing else you remember the question mark is what separates these two, and then the parameters are separated with an ampersand. So post the question mark, ampersand splits everything up. Before that, it's just your backspaces. All right, so hopefully I haven't chewed up an insane amount of time on that. Let's get into...
Well, we have about 2 minutes left.
Awesome.
I'm just kidding. No.
Well, that's it. I'm done.
Thank you, everyone, for tuning in. But now for the live demo, which you were going to say.
So one thing we're going to touch on super quick. Postman, if you aren't familiar with REST at all, Postman is your best friend. It's free. It is the GitHub of restiness. It is a sharing environment of restiness. And again, from the Autodesk side of things, if you're looking down that space, the Autodesk developers, if you go snooping on their GitHubs, they provide all of these files, and you've got all of these pre-built REST commands. Again, the GET request, and I'll show you some working examples of this, but I just want to highlight Postman is awesome for getting and understanding predefined calls, and you can make them, and you can see patch and post and create issues, all of that. So we'll touch on that a little bit more, but download
Well, I have to
Postman
say thank you to whoever pre-built all those all those examples.
The dev team does heaps of them. So if you do a hunt around Google, there's and then if you go to Postman as well, there's like you can sign in and share them with your team as well. So if you're creating other tools, you can, it's really, really good. So you'd be crazy not to use it. All right, so delving into the details. So what we're going to do is we're going to use a fast API, which is a Python REST service that is designed to be extremely, extremely lean in creating REST services. So I'm going to build that locally on our machine. Once we get that working locally, which hopefully doesn't take too long, we are then going to post it to Vercel. Now, Vercel is a free web service. It does have a paid tier, but it's got a free tier. You can sign up for free. We are going to post our code to GitHub, and Vercel has a full CI/CD integration. So every time we make a commit, Vercel will grab your code, automatically bundle it, compile it, check that it runs, and then post it on the web, which is really, really cool. So from a developer point of view, you don't have to do any post ops other than press the commit button, which is awesome. After we do that, without a database, it doesn't make sense. So we're going to use Planetscale, which is a online scalable database, can handle up to 1 billion rows. So again, we were talking about this earlier, Timon, but AEC versus real world, people go, oh man, I've got like 10,000 walls. Free tiers of these databases starts at 1 billion. So again, it shouldn't be too difficult to really make use of the free tier. And then we're going to connect the two talking. So you'll use our REST service, that'll then update the SQL database, and then we'll hopefully get through where we can show it running in Dynamo and Excel and all those things as well.
And if you want to see that and you want to help others see it, smash that like button. Thanks.
So let's go from scratch. So what I'm going to do is create a brand new repository. There we go. We're going to have the Yodesk. This is going to be live. This is going to be public as well, so you guys will be able to see it. And add a README. We're going to use a git ignore, and you'll see how this works soon. And I add an MIT license, so you guys, I won't sue you if you use it, I promise. Create that repo. So again, if you're not on GitHub, go and sign up for GitHub. You press a new. I've now got a GitHub repo. So let's jump across into, what's this tool called again? Visual Studio Code. Normally I'm a Visual Studio guy, but with anything Python these days, I use Visual Studio Code. So what we're going to do is we're going to clone the repository. So the way we do that is we go and get the web link, or the REST interface, if you'd like to call it that. That's not really, it's just a web link. We're going to come back to here, and let me just do that again. Clone the repo, boom. It's going to ask me where I want to save it. Try not to look at too many of my files. There we go. So I'll just dump it into this repo here. So it's just cloning that down. Would I like to open it? Yes. All right. So pretty simple. We've got 3 files into this thing. So we've got our git ignore, our license, and our readme, and we'll update those a bit later. So since we're building a Python setup, we need to do some basic kickoff things. So with Python, and Tim, I think I was watching one not too long ago. The very first thing you want to do when using Python is create Python environments. And so what a Python environment is when you've installed Python on your machine, if you just start sticking all the packages in there, you end up in this package hell, and then all your projects don't work because they're on different versions of packages. So if you're not familiar with Python, just think like Dynamo, except everything's on different versions. Python environments can manage that. So if I do this, what it's actually doing is it's just created this Your Desk Python environment, and it's loaded all the scripts, so everything from Python executes just in those folders on my computer. So the next thing I'm going to do, and this is a Windows specific thing, is I need to activate that environment so it knows it's running in it. Typically I use PowerShell to do that. And what it's going to do is it's just going to tell me now, cool, you're now running in the Your Desk Python environment. After this, we need to update the package manager. So the package manager is pip in this case. So I'm going to hit that. This will just download the latest version of pip, make sure I've got all the latest stuff. So there we go. So now there's only 3 packages that we need for this. One is Fast API. So this is our interface that handles all the rest and does all the clever stuff for us. We've got another package here, which is UVcorn. UVcorn is a package that allows you to run on your local machine as a REST service. So it's pretty clever. It sets up your computer as a REST service for local debugging. And the last one that we're going to use, which we'll touch on a little bit later once we've got the SQL running, is PyMySQL. It's just a SQL library. There's a bunch of them. This is the one I use for this exercise. There's you figure out the one that's right for you. But I would use this one. Now, once we've done that, what we want to be able to remember all these packages we've set up. So there's this command called pip freeze requirements. And what this will do is this will create a lovely little text file in our code base, and it'll list all of the things that we installed. Right?
I was pointing to it on the screen. That's right there.
Oh, cool. Sorry, is that a bit too small? Is it
no, it's great. It's great.
I'll be dumping all of this in the README file in the repo as well. So all of these instructions will go in there. So this is super important because this is when you go pip install requirements, it'll automatically install. They'll all be these versions and all of that sort of stuff. So make sure you do that. All right. So now we're ready to do some coding. So how are we going to do this coding? So first off, I'm going to create what's called an init file. You don't need to worry about this. This is just a Python file that allows you to specify modules. We're not going to be doing anything with modules, so I'm going to leave it blank. It's just good practice. The next one I'm going to do is my main file. So with my main file, this is where our main application is going to run. So one of the tools that I got access to, I think on the weekend, I was tweeting about it with you, Timon, is GitHub Pilot Chat. Now, this thing is pretty game-changing. So prior to this, we had GitHub Pilot,
and
it kind of try and do IntelliSense. So what I'm going to do is I'm going to go, okay, create a Hello World Fast API example. Sometimes this thing thinks for like a minute. Hopefully this time it gets the job done. Hey, cool. Boom. So now there's my code snippet. If I'm pretty happy with that snippet, I can copy it. I can just inject it straight into the system here. And so it's imported my library, Fast API. It's created my Fast app, which is my REST service. It's created the initial GET request. And then it's got this async def route. Now, the really nice thing with this is anything you're not sure about, you can just go Copilot explain this. And it'll start going, oh, hey, this is what's happening, blah, 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 and it'll give you some depth. So if you're ever not sure, you can just get it to talk. Now, one of the things I would do in this Hello World example is it had an asynchronous command at the beginning. And async is useful when you need another service like our database later to do something, but we don't. At this time, we're just returning this string to make sure the whole thing works, so we can just return what's called a standard definition. All right, so there is our Hello World tutorial done. So what I'm going to do is load it up. Now, this is where the UVcorn stuff comes to play. So UVcorn has this awesome feature, I know it might be hard to see, called Hot Reload. And so what it'll do is the web service has just started. If I click on this, you can see there's a little request to let me know it sent that 200 codes. Remember, we're talking about the 200 codes back. And if I come up here, there's my beautiful hello world code. All right, so very, very nice. Now, one of the really nice things that you can do with hot reloading is the system's still running. So what I'm going to do is I'm just going to do this very terrible summing in here. So putting some logic into this thing. I'm going to add a variable to just put that sum in there. And again, notice the IntelliSense kind of figured it out. And as soon as I hit save, that's going to recompile. And that should be done. So if I come back up here, run this again, it's automatically running that calculation. So I don't have to do this debugging. I don't have to do this. Now, the other really awesome thing with Fast API is this automatically documents your API. So there it is there. So as soon as you do this default docs, you get this full breakdown of like, hey, there's your hello world. You can try it now. I can hit execute. It's going to be like, hey, I was able to send a response. Here's all the successful responses. This is the data we're sending back. So as you build this thing out, the documentation's automatically included. So that's really, really cool.
Yeah.
So
can't
yeah.
hate auto documentation. That's for sure.
No, I suck at doing normal documentation. So AutoDoc is awesome. So what I'm going to do is I'm just going to stop this because the auto hot loading's great and it's a really good way to work. But maybe you want to step through your code. You've got a few things happening and you want to do the debug. So what I'm going to do is I'm going to click on Run and Debug, and I'm going to use this create a launch JSON file. And so down this list, I'm looking for Fast API because that's the service I'm using. Boom, it's created this code automatically. And then down here, you can see main.app. And all that is referring to is the main file and this app here. So it knows that it should be running that. There we go. So with that running now, I'm just going to put a breakpoint. And let's step through this code. So if we step it, I'll just put the breakpoint at 1 + 1. We hit the sum. There we go. It looks like it's fired up. It's looking like it's running. And one thing I'm going to do just to highlight this is if I scroll down and get this request parameter from here and I go back into my Postman, I'm just going to create a quick GET request in Postman just to show it works everywhere. Hit the send. It's waiting for the response. My application's popped up to go, hey, I'm debugging right now. If I step through the code, boom, there's that sum too. It's done that calc and return that response back as well. So, and if we come back to Postman, we can now see our hello world too. All right, so there's a debugging version of the code. There's the hot reload of our code. There's all those pieces to get working. So what we're going to do now is we've tested it working on the local app. Let's push it up into the cloud and watch this whole thing run from the cloud. So there's only one other thing that we need to do. It's one of these things that you've just got to know that exists. When we're using Vercel, and I did try and do this with Google Copilot, and it worked 50% of the time, but I'll just paste it in properly. We need this, just this little Vercel JSON file, which basically just tells it like, hey, when you're compiling me, make sure you look at this main PI and make sure you look at all the source code from main PI. So just a simple little script there, and we're ready to commit. So if I come up to commit, and we have a look before we hit the commit button, notice it's got like all this py execute. This is not all, this is the environment that we loaded earlier, and we don't want to load this stuff to GitHub. It would not be good. It's a bunch of clutter. So one of the files I included in here earlier, if you go under your git ignore, and this is what this thing's for, is we can go, okay, ignore. And what I want to ignore is this your desk. So we want to keep the your desk in our local environment, but we don't want it in our main dev environment. So see how that just went from 16 down to 6? There's all just the code that we care about. And usually what I do just as a backup, if I come down here to our, environment stage, I usually just throw it here too, just in case.
And you're not totally eliminating Your Desk University as a web service here. You're just limiting the folder from going into Git.
Correct. Any of the contents in the folder just won't be uploaded to the cloud, because this comes back to when you do that pip install, those requirements will automatically get installed on everyone's machines. And it's just best to pull it down from the packages. It keeps the system a lot smaller, and you're not dealing with like when you commit a new package, like 700 packages you just included in your app.
And my
So
joke about YouTube getting removed aside, the requirements.txt helps to replace that on a new computer, right? That tells you which
yes,
packages you need.
yep, 100%. So we'll do our initial commit now. Boom. We'll sync these changes. Excellent. So it's spinning. Let's come back up here to our YouTube GitHub. Do a quick sync. Hopefully the data's coming up. Yep, there's all our data. It's now just populated. So what we can do with Vercel is if I come in here to add new project and I click, and again, this is one of these ones where sometimes it like goes really slow. And then if I refresh it for some reason, hopefully it still speeds up. And so we're just going to import that repo. Now I'm just going to drag this over here because I might have to put my password in there, and I don't want to do that. So all I'm doing is going through my list of repositories. So it's connecting to my GitHub account and connecting it to that installation. There we go. So it's just connected that Your Desk REST request from my Taco GitHub, import. You can leave all this configuration. I leave it as standard, do a deploy. So that's automatically pulling that data straight up from GitHub, compiling it. It's doing all your building deployment status if you set up any tests, and it'll do all of it from here. So again, this is a really, really cool free service. Excellent. My project's now deployed. Congrats to me. Hooray. You can see that it's working because it's giving me a preview to show like, hey, there's no errors when I tried to do this thing. And so if I click on this now, we get this amazing, now it's coming from the web. We click over here and we do another test from our Postman app. Boom, we get the web. We can see that it's coming from Vercel, and there's a bunch of header stuff here. And so there's our initial REST application sorted. Okay, so doesn't do very much, obviously not very exciting. So what we're going to do now is we're going to set up a SQL database, test that the SQL database works, and then start adding and removing all the records to that. So the tool I'm going to use for that is this one here called Planetscale. Again, all I've done is signed in, so I'm just going to create this new database on the fly. I'm going to call it test database. We're going to see some security keys and stuff coming up in the next like 10 minutes. Please don't
I
like
can block.
flood
You
this
just let
thing.
me know, and I could just
Oh,
block
it
it
doesn't
from
matter because
YouTube
I'll
for a
delete the
moment.
database like 10 minutes later.
Okay.
So it's only if someone out there is like super ambitious and wants to like hear my talk for like 10 minutes. So creating the database, done. So that's just setting it up right now and just initializing. Now, a really cool thing with Planetscale is you can do branches of databases. There's deployment, there's insights, there's all of this analytics built into it. It's got, like I said, free tier up to 1 billion rows, 10 million writes, 5 gig of storage. Really, really cool tool. Again, so yeah, I'd highly recommend Planetscale. It just does the database stuff, but yeah. So while that's deploying, now we need to populate our database. So we're going to do something pretty simple. We're just going to create a table called walls. Our table called walls is going to have an ID. It's going to have a name. It's going to have a length and a volume. So 4 records. So I'm just going to connect. Now, at this point of connecting, this is where I have to type SQL. Now, I might not be very clever at SQL. And so I'm going to come back to my trusty friend Copilot here and going to be like, hey, create a SQL query that creates a table, and make sure I spell properly for walls with ID, name, length, and volume as columns. So hopefully Hub Pilot is like, hey, yeah, I can crank that out, man. It should look something like this. And I'm like, oh, okay, that looks pretty good. So I'm gonna grab that there and go in here and I paste it in.
And I love how you're using AI, but you know whether it looks good or not.
Oh
Right?
yeah.
That's
Like
the
if you,
catch with all
yeah,
of that.
yeah, like and if you break it down, SQL queries are pretty easy to read. Like we're creating a table called walls. It's got an ID which is an integer, which is the primary key, so it's the main key. So you do need to know some. We got a name which is a character up to 250 strings, and it cannot be null. We've got a length which is a float, which is a decimal place, which cannot be null, and a volume. So if we wanted these to be able to be null, we could delete these and things like that. So, and just to check that this works, we go create 5 rows of data to insert in my walls table. And this is where it's really cool, right? So normally you'd have to start like, oh, I need to figure this out and write all this, but like it's gone and like done all the hard yards for me with creating some synthetic data. There we go. So again, just paste that in. Thinking, looks good. Now, the last query I'll write myself, I'm just going to check that the data actually exists. So I'm just going select all rows from my walls. Make sure I put the there we go. And there's that data now into the database, right? So what we want to do is, this is great. The database is now working. We want to connect this back to our REST service in the code. So if we come back in here.
I just want to pause because that's a cool trick for generating data.
Oh yeah,
I haven't seen that before. That's a nice one.
Where this is really, really cool is you can take like big snippets of data out of like contracts or really messy data, feed it into like Bard or any of these and go, hey, I've got this big mess. Can you turn it into data that looks like this, specify the format? It'll automatically, like big email lists. I did this for my wife the other day. She had this huge list, came on this janky PDF that got sent from the school list. And it's like, hey, can we get, I'm like, yeah, reformatted it all perfectly and was able to turn it into a mail group. So where people might not be using ChatGPT and these things is turning unstructured data into really structured data or generating synthetic data really, really quickly. So
I've seen the structured data thing. I haven't seen the like, I need 5 rows. I need 500 rows. I need 1,000 rows of fake data. Give it to me. That's pretty powerful.
Yeah. So yeah, no, it's really handy for those sort of things. So, so coming back over across to here, we've got our data there. Let's start generating our code to connect this. So first off, we need to create a connection. I'm not going to use AI to write my connection string just because I won't use that. So a connection is basically the way that our REST service is going to be able to connect to our database. So I'm going to dump in what's called this connection. You can see it's missing this my PySQL. So I'm just going to import that library because that's all it's saying it's missing. Get rid of that. So I know it's got this. I know it's called test database. I just need this username and password, and I'll get those in a second. But the other thing here is I got this CA cert. And what CA cert is, most of the web uses a transport layer called SSL to communicate. SSL requires certificates that encrypt your data between client and server. And so I'm just grabbing the default one from Mozilla. You can download, they provide it for free to everyone. And Planetscale is built to work with that level of encryption out of the box. So now that it knows that, it knows to use that as the one to send the encrypted data so that the database can make sense of it. So what I'm going to do now is just come back to Planetscale. And I come back up here to my overview. And I'm going to go get those connection strings. So in this case, what I'm going to do, I don't want to give the full admin rights. I just needed to have read and write access to the SQL database. Create the password for that. These things disappear, so it's a one-time password. So again, come back in here, put the username in there. Go back
sell
up
that
here.
on the black market.
Yeah. This data, you've got 25 minutes. Please don't ruin my database. It'll ruin this demonstration. There we go. So we'll save that. And that should be the setup. So let's test if this works. So again, I'm going to be lazy and be like, hey, create a get request for walls. And it should be remembering a lot of that context. So there we go. There's my request. It's actually dumped the whole thing out, which is interesting. I'm not used to it actually doing it like that. That's gone and added the connection string in there for some. Oh, it's probably because I haven't saved it. So let's I can probably grab this. I might just try it one more time and see if it can have a second crack at that. Yeah, no, it didn't. All right, we'll come back up here. So again, it is going to always vary on how it works. So you do need to know what your code is actually doing. So I can tell from here, I don't need the connection string. I do want the get walls. This is just grabbing the connection from above. Here's my that SQL query that I did before. The result is fetch all. It's closing the request after that and returning my result walls. So there we go. I'm just going to save that. So now what I'm going to do is test that it works. So I'm just going to run my UV again. So it's going to fire up my little documentation setup, and I come in here. Again, I'm lazy. I'm going to go to my docs to actually run this because the documentation is always a really good spot. So see how it's automatically added my get walls request, and try it out. Hit X, and there we go. It looks like it's run. There's all those walls, all the fake data we just loaded up to the database. So we know that the database is talking to the REST front end, right? So this is where we can hopefully get clever. That's the first time I've ever had that really janky Copilot request. So that's annoying. But now let's see if it remembers all this. So now I want to go create a get request and make sure I don't have spelling in there. For sum of wall volume. So we want to sum all the wall volume, turn that into a little get request. So let's have a look at that one. Keeps dumping a connection string in there on me. That's fine. I'll
You could
deal
say
with
say it again without the connection
yeah,
string.
let's just say remove connection. Remove
I don't know if
connection
Copilot
details.
has history or not.
It kind of does. It's still one of those ones where it's like 50-50. Let's see if it cleans it up. Yeah, now it's just the history goes a little bit off. So anyway, that's all right. I'll just keep grabbing this and dumping it. It's still not too bad. There we go. So, all right. So now we're getting an issue, which is fine. We need to get rid of that connected database. The rest of it's good. So this one here is saying, and this is the thing, it doesn't always get it right. So it's going this fetch one. So what I'm going to do is, again, I'm super lazy. So I'm going to see if Copilot can actually fix it. So it's going to have a look and see if it can come up with a way. So if result is not none, result equals result 0. That seems pretty acceptable to me. So I'm going to run that. There we go. And again, as soon as I hit save, that is uploaded, so I know that it's building fine. So if I come back now to my documentation and just do a quick refresh on this, there's my get wall sum, try it out, boom, and there we go. It's returned the number. Again, why is this a big number when I only have 0.1? Because floats suck, and we could go and ask it to like round it up and all of that sort of stuff. But that's essentially why it's not 221.6. All right, so we'll just create two more queries here, and this will be interesting because I was hoping this would be create get. No, I'm going to create a post request to add wall without the connection details. Include ID. So let's see how it goes at creating this one. Oh no. That's all right. Let's try that again and going. We might go if that's going to go all the way back. Let's try using fast API. So again, the more contacts you can give it, and that sort of thing is usually a good one. So what do we got? Connect well. Use.
Oh, it made a class for you.
ID. Yeah, I didn't want it to be that fancy. Length and volume as arguments. It's worked.
This
it's
is
worked
one
the
of the
last 2
things
days.
about AI, though. Sometimes, like, it gives you what you want. Other times, you're like trying to negotiate that it give you to give you what you're looking for.
So what I might do is just to speed this up. I'll do a let's see if I can do it this way. See if it's clever in context, and then if it doesn't work this way,
Copilot over there running too.
Yeah, you can add Copilot over there everywhere. Post request to add. Whoa. So again, it kind of sits on both, which is nice. So we'll try this last one, and then if it doesn't like this, yeah, that'll do. I don't know why it's doing the connection thing on me at the moment, but that's okay. I'll live with it. What do we got? Get. Where did my add go? Post. Oh, it added it up the top for some reason. That's fine. So wall added successfully. That's cool. And then, yep, application started. And I might just add one more up in here for the delete request. So I can add delete request. And then we should be right to now move this thing across. No, I don't want Docker on this at the moment. So hopefully, there we go. Add a delete. Well, hey, that looks nice. That's what we normally want. So it's just executing a delete request. Boom. So now I've got my delete. Hit the save. Cool. Application started back up. Let's come up here, jump back to our Swagger documentation, do a refresh. There's all of our different things. So again, what's really cool is if I click on the get, ooh, it doesn't have ID. I need the ID in there. So I'm quickly gonna fix that. Where is that? I'll just do this manually. Let's place these all over the place for some reason. Let's just go ID, int, name, string. And then I need. This is going to slow me down. I'm wondering if I go fire up one of
You're
my
good.
old
You're
ones
good.
just
You're
to
good.
copy
Just
and
keep
paste
rolling. We'll keep rolling. We'll
Alright,
we'll roll with the
as
punches.
long as you.
I was gonna tell you were missing the comments, but you got them. So.
Ah. So volume.
And as
Right.
he's doing this, like if you have questions about what he's doing, about REST, about how he's using GitHub Copilot, about what experience has been, feel free to put them in the chat. Put them in the comments below. You can always find us on the Discord if you're interested in which you can find at yourdeskuniversity.com. We're happy to kind of keep the conversation going two ways.
Yeah, it is funny. It has actually been working really, really good, which is why I picked it. And as usual, demos never go perfect. All right, so looks like the app started well. Looks like it's going to work okay. So let's jump back in, do a refresh on this again. Cool. So now it's like posts. We got the ID name, so let's try it out. So let's put in ID 50, Adams Wall. I can't spell wall. That's okay. Put a 10 and a 20 in there. Again, execute. Yep. So again, there's that REST request. So notice again, we've got our address, we've got our URI for walls, we've got our question mark to separate, and then there's our parameters. We can see it's added successfully. Now, one thing I want to point out here, this all looks good, except it's a 200 response. What it should be is a 201 response. So again, if we're trying to be good, consistent REST API developers, which we should be, we change that to 201. And what that means is it is going to update the documentation now. So if I run a quick check on this post request again now, it's now telling us that it should return a 201 successful call. And if we were to go back to my get walls, try this out super quick. Where is it? There's Adams. Wow.
Nicely done. And if anyone's wondering why I'm here giggling, it's because Matt Wash in the comments over here is saying that we're going so fast that he can't keep up. But anyways, no, but actually that's perfect because that's what we need on YouTube, Matt. Just kidding. I'm gonna heckle him, you know. And yeah, because we always go back and replay. Now I've so many times I'm gonna have to like clip out that section. But yeah, keep the comments coming, the questions, anything.
Yep. Keep it coming up. I'm almost through. So now, delete wall. We type in the ID of 50. We run. Boom. That wall is now successfully deleted. And if we were to come back up here and run all these, there's my dog. He's yelling at, I don't know, invisible things. But the Adams wall was deleted, right? So the API is now pretty standard to what you'd want to do stuff. You're grabbing stuff, you're adding stuff, you're doing some sums, we're deleting some stuff. Very cool. Now we need to get all this on the web. So the way we do that, we don't have to do a lot, but we do have to change a couple of things. So first off, we need what's called an environment file. So one of the things is if you just go and commit this code, one, this is really, really bad. You never put security credentials on your GitHub or anything because people can take and do all sorts of things with your data. Two, what's really, really cool, let's say you accidentally do it, Planetscale will automatically recognize because your connection is there has been compromised and will delete those credentials automatically from their website. So it's one of these ones that if you're not being safe, and it took me a while to figure this out when I was going over this tutorial, I'm like, hey, what's going on? It's because I kept posting the keys to GitHub because I was being lazy, and Planetscale was like, whoa, I've been compromised, kill that connection. So it's actually really, really cool that it's able to figure this out. So what all this means is we just need to create what's called an environment file. So similar to the Your Desk stuff, we just need to put this stuff over here. We need to grab this main file, copy some of these credentials in here so they're safe in this environment file. There we go. And then what we're going to do is we're just going to swap this connection. So currently we were doing this direct connect. We've just got to change it so it uses what's called a host environment set of credentials, which looks something like this. I need to import the OS, which is the operating system. And what this means is when it gets loaded up into another system, most other systems have a similar sort of system called get OS environment or get environment or something like that. This will start breaking now because I've changed it to where it's directly trying to grab this data, where it's now being set up to run on Vercel on the web. So this isn't going to work properly anymore because it can't connect because it's trying to do this local host. But this is how you should set this up. Now, what this means is we have to put this data somewhere else on the Vercel website. So we'll just come back into here, come across into my Vercel, come into settings. There's a feature here called environment variables. We copy and paste them in. So that is where when we upload the code, it's going to know to look there for that data. And so we come back in, all looks good. Is it going to work? Let's hope so. Let's do a
And so as
commit.
you're
So we're
doing
gonna,
that, you preempted a question I was going to throw out there about these passwords and safety. So on our local computer, when we're testing it, that .env file allows us to have those environment variables, but then you're copying them into, I think it was, which application was Fast, and Fast API and putting them on there. But the
yeah.
.env files, actually, I just want to say to those who aren't as familiar with Git, isn't actually getting pushed to the GitHub. So that is only a local file, and that git ignore has env in there to avoid those being pushed.
And usually Visual Studio does show this. So see how they're slightly grayed out? It's just a helpful little visual indicator that they're part of the git ignore. So it should be there.
That's
so
nice.
now we
I
see
didn't know that. I'm sure I have
it's
it, but
part
I
of the
just hadn't.
insiders.
I'd
So
missed it.
yeah. I don't know if it's part of the original because Copilot at the moment only works with what's called Visual Studio Insiders, which is like the beta version if you want to rock that. So I've done that commit now, and then let's come in here. Again, similar to Planetscale. Cool. That's already been deployed, so it looks like it was created just now. What's really cool, again, with Vercel, it'll remember every single previous version of your app up to a certain number, so you can actually go back automatically from here and run older versions of your application. You don't have to recompile code. If you stuff anything up, like you don't put those credentials up, you can just click on this and be like, hey, I stuffed up, redeploy this. Got a whole bunch of analytics, speed insights, so you can actually get into, and we can look at that in a little bit, but like how fast your queries are taking to execute. Like again, Planetscale and these things for new, beginner developers are fantastic, and they're good for senior developers because I'm a really lazy developer. The less things I have to do is good, and if all I have to do is commit and then my system is rolled out, that's awesome. So again, if I come through here, I can get all the walls. I can just quickly test that this is all running. Great, the walls are all uploaded there, so it all looks like it's running. Again, if you're not 100% sure, we can do a quick secondary check. One thing to point out is I haven't authenticated this. So what this means is if any of you guys wanted to like plug this into the web browser, it would work. What you should be doing is using authentication with this stuff. We obviously don't have time. I think we've done all right considering what we've done. But the authentication method that you would use, the out of the box one that's really good is what's called Auth. Fast API has automatic integrations with it. You can go set up free account for up to like 10,000 users. So Auth is the one, and that's part of the Okta stuff. It used to be a startup, and then the Okta guys acquired them. So go look at the Fast API documentation, but then you can add that so it'll ping you for username and password. So
And I'm gonna post the URL here. That's the Your Desk
grab it.
REST walls so people can see it. And I am going to ask a question. I think for those who have done this, some level of REST, they can understand the relationship here. But you had started by talking about Autodesk, talking about Forge inside of Postman a little bit. Can you make the connection for maybe a more junior developer who's, just getting into web and trying to understand how does this work with what I'm doing in Revit, or how does this work with what I'm doing in BIM 360? I think this is great. I've really appreciated what you've put together, and I'm sure you have more, so we can jump back to that.
Yeah. So the main thing here is we've got this service up and running that can ingest data from basically anywhere, right? And more importantly, it's built on the same way that the whole Autodesk ecosystem works, that the Procore system works, that Trimble works. Like everyone is using this same REST standard to get and post data. So what that means is we can start grabbing this. I'm doing this, through this web, but we can start doing this through any source. So an example of this is with Excel, right? So let's come in here, create a brand new sheet. What I'm going to do is I'm just going to go get the data from web, um, paste my request in. So this will be a little bit hard to see, and if you haven't used Power Query Editor before, I'm sorry you won't be able to see it very well. But what I've returned is I've got my list here, and I
Let me
can't
full
zoom in
screen
on
it.
this, otherwise I'd zoom it, so it kind of sucks. This is the list of those records directly from that database. I can convert this list to a table. They've changed this recently in Power BI. I can extract the values from this table, and I'm just going to separate the values from a comma. So now, and you'll see this when I turn this back in. And then all I'm going to do is split this into columns because it's just created an individual row for each record. I'm just going to split them by that comma. There we go. Load that back in. Just grabbing that data now, zoom in. So there's that data straight from the SQL database. So this is where we can start doing things like if you've got engineers working in one system, your own internal REST API service can be like grabbing data from Forge. You could be grabbing data from all of these things and sort of being this bridge in between multiple systems with your own services. And for updating this data, so if I finish off, I don't know if anyone's seen this model before, bit different, something new. Simon, I don't know if you've seen it.
Interesting.
Some, yeah.
Yeah, this is
Uh,
very advanced.
so I've got again. I'll post all of this up in the GitHub as some data sets that you guys can look at. So quick shout out to Radu from Cope who built this one. Built up what's called DynaWeb. It's just a bunch of Dynamo packages with REST built into the core of it. So again, you can get this stuff in Dynamo. So I've just created some really simple, he's got some really good documentation. So again, I've just got my REST app here. If I run it, it's going to run through. You can see the hello world message has come out, which is what I want. If I freeze that and then just open up the unfreeze here, and I'm just going to get all of the walls. And so they got this really nice thing like, yes, the data's here, but it's a bit of a mess. They got this nice little helpful deserialization. So again, the same data you saw in Excel, now straight in Dynamo. And then finally, similar to before, if I come and freeze this, one thing I kind of sucked at DynaWeb, so I didn't know exactly how to craft the string properly. So I kind of built it this way instead. But all I'm doing is grabbing a wall, getting the element ID, getting the name, getting the parameter length. I just used underconnected height, but I should be using volume. And then I'm just turning it into a big string that looks something like this, right? So I made I've just got to tweak this back because I know something went funny on my last one. So I'll just double check that the post is right. So I'm just having a look here. So where is the post request? I'll do this quick try, and then you'll see all this update, and then you can see it. So I'll just execute this real quick, or maybe not so quick. Ooh, did I kill my post request? Read integer. Ooh, what did I do?
Matt Wash is over there pinging your server so fast that
Yeah, is anyone like, totally pinging the server so it's slowing down? It should have returned an error by now. I was gonna show my final little bit, but that kind of sucks. Oh,
while that's
hope if
coming up, another interesting, you were talking about getting data from anywhere. Another
Yep.
interesting place to get your data from is I don't know if anyone has been exploring PyRevit routes. PyRevit routes is the ability
Yep.
to turn Revit into a Flask app, like is what being described right here with this API, where you can actually build directly on top of Revit an API that you can get and post to. But then obviously your get and post has to read and write to the Revit as the
Rabbit.
database.
I figured out what's wrong. I'm still got the web open from the local server.
Mm.
Rookie error. All right, so let me try that again one last time, and then we should Well, what are we on? 1 minute over. Sorry,
Oh,
I got you
wow.
guys.
I never let people go over an hour. This was just so exciting. I was loving it. It was going so fast. That
All
being
right.
said, go ahead and hit the like buttons to help everyone else. And hey, Andrea, and bye, Matt.
All right, so we'll grab this last bit. So I just had the ID equals 10, so I've just got to add that part back into my script because I know what I did now. So that should be sitting right there. Now, if I am correct, that should be an ampersand as well. All right, so let's give it a test. Unfreeze. So now you could have this send 1 record, you could have this send 50 records, boom, wall added successfully. And again, back in here, all I have to do is under data, do a refresh, and there's that wall back in. So again, very, very simple, but full end to end of just how you add, remove assets. As Tim had said, all of the services, like you can build this in Flask, you can build it, there's like a number of different ways to approach it. So again, no right or wrong answer, but it's once you get your head around how REST is working on the back end and then how it's working on the front end, you literally can interact with virtually any web API on the planet. So I found that when I first got into REST, building something like this really, really useful as I understood what it was doing in the back end, so I could then reason about how developers might be doing it. And so then I could, oh, okay, I would expect getting projects to work like this. I would expect this to work like that. So I find building these things yourself adds a really good dimension. So I'll upload the README, I'll upload the Excel file, upload the Dynamo script, all of that stuff up there for you guys as well, and some instructions. So that repo is now live.
Well
Yeah,
done.
and
Well
back,
done.
man. We
I
got it
think
done.
everyone hit that like button. Give us a thumbs up in the chat. I see people saying so cool. Nice job. And seriously, I really appreciate you putting so much work and effort into this presentation and going through at a simple level, but at a level that really is relevant and doing it as a demo. Can we walk through one more time as I'm looking at other questions that might come up?
Yeah,
Can we
please.
walk through the stack that we just created? So we have a fast API.
Yep, we have a fast API. That's the basically the API for all the REST
Mm-hmm.
services. We have PyMySQL, which is just the tool that knows how to talk to a SQL database. So
Okay.
it's not specific to Planetscale or anything like that. It's just that. And then the only other package in here, well, there's two, sorry. OS, which is just the operating system to call the environmental
Mm.
credentials. And then the one that's sitting here, but is in the background, is the UVcorn. And UVcorn is just the one that acts as a web service. So we never load it in, but once it's in the terminal, that's how we're able to run it automatically with that
Mm.
reload that does so that's where you can do all that really fast testing on your local machine before you publish this stuff up to a
So
web
UVcorn is
service.
an app that's running on your computer that's running the API locally.
Yep.
Fast.
It's just a simulated web server,
Yep. Fast
basically.
API is that's actually also the place where you were posting this, right? You were using Fast API.
Oh no, where like which web
Where were you
service am I
hosting the
using?
API? I
Oh
can't
yeah,
remember.
yeah. So everything I'm using is a product called Vercel.
Vercel.
Vercel is awesome for two reasons. Because Vercel, you can host any front-end web service on this. So it's designed actually for, these are the guys who own Next.js. They're the maintainers and builders of
Okay.
Next.js. They've got their own databases and stuff like that now. They've got storage and all these other things. But if you're building React web services, you can use this same thing. It'll automatically build a compile it and stuff like that. But what's really cool is if you're building Python, I think there's 3 or 4 other languages, it automatically recognizes their serverless functions and can turn those automatically in apps as well. So it's really clever. If you're writing React, it'll turn it into a React app. If you're writing Python, it's like, oh, cool, you're writing a backend. It's got integrations with Flask and all that. So as a developer, you just don't have to worry about any of that stuff. There's a whole bunch of integrations here. There's activities and stuff. And again, really generous free tier. Really,
Mm.
really
Mm.
generous free tier.
That's
This has its own post reg SQL database too that was added maybe 3 weeks ago in their latest new set of features. And then the other one, and then you got usage and monitoring statistics. Like you can get into like, how much it's working, what executions were happening, like down into your
That is
log
pretty
files, you
powerful.
can
Yeah,
do
I've
that.
used Firebase, and I imagine
Oh
Firebase has
yeah,
a lot of the same features in it. It's also super easy to deploy to. Right, they made it one command,
yeah,
which
yeah.
is nice. I'll definitely have to try Vercel.
Firebase has some of the and I've used Firebase not for recently, but same sort of thing. Like it's got some of the added advantages with like the authentication stuff and all of
Mm.
that. The biggest issue is their Firestore database. Like it works, but it's not a standard SQL setup. So you really need to stick with that flow. Whereas a lot of the web technology out there, if you're trying to take stuff from industry, is predominantly SQL.
Yeah.
So yeah,
Speaking of which, I
but you
did want to ask your thoughts on SQL versus Mongo, or no SQL.
uh
Mongo being one of those.
Well, the whole SQL versus no SQL debate, I guess. SQL is great for relational change management. So if you've got data that needs to be consistent, relational data that needs to be consistent. So if you've got a project, a table with projects, then that table has an individual project table that might have a list of walls, and all of this stuff has to be kept in sync. That's where relational databases work really, really well. When it comes to NoSQL, and Mongo and these other things can do this stuff. So ultimately, too, the biggest thing it comes down to is if you're really familiar with one, just use it. That's that. Same with languages. If you're really familiar with that language, there's no better language. They all interact
And
with
that's
the
that's
CPU
a
and the
good
memory in the
segue to the
same way.
last couple sessions we've had that have been about Python development for the web, because people were more competent in Python, and there's places that you could do that without having to learn JavaScript fully in order to create a front
Yep,
end, right?
yep, yep.
And
hundred
cheers
percent.
to all those BIM and VDC folks out there.
Yeah.
Um,
And like with BIMBeats is completely developed on a NoSQL database called Elastic. And the reason it's developed on Elastic is very good at cataloging and storing log data and then iterating over it.
mm,
But we're rarely changing the records. We're
mhm,
always ingesting masses and masses amounts of data, like hundreds of millions of records a day, but then we're aggregating over it. So it's a very different thing to like, I have this complex thing and I need to update this, and these other things need to recognize that's updated, and you've got all these sort of prerequisites. This is really, REST is and those sort of systems are really like chunk it all in. We can aggregate it and mash it and turn it into analytics later. So there are definitely databases built for specific things, but if you're trying to do um, data that's highly relational and up connected. Yes, there's a lot of people out there with their new flavor for the month, but there's a reason why SQL is still popular after 50 years. And everyone, you got to remember, like, SQL has had 50 years of development of Microsoft and of all the guys at MySQL. Like, think of the thousands of developers that have been working on these things. So sometimes the new flavor of the month looks cool and all of those sort of stuff. But when you get down to it, you think, how many millions of hours have gone into solving the
mhm,
problems in some of
mhm.
these older stacks. So
Yeah.
definitely nothing wrong with them.
Well, thank you so much. I'm going to cut it off there. And thank you to you all on YouTube for being a part of this whole series, bringing web architects to the web and the web to architects. It's been a pleasure. We are now on, I guess, I don't know how many it was, 14 or 15 sessions in this series. But thanks to Adam for being our closer, and we will see you all around. If I can remember. There we go.